Page 37, understanding proportions. Okay, so a true proportion is just an equation that states that two ratios, it's always going to be two, are equal. We can use proportions to figure out how we could be increasing a recipe or enlarging or reducing an image so that the dimensions stay in the same proportion so that things look proportionate. The first thing we want to do to identify a true proportion is to make sure that the units are consistent. We can have consistent units either vertically or horizontally. Either one will work. So for example, we could have miles per hour over miles per hour, where these are consistent horizontally, or we could have miles per mile over hours per hour, where they're consistent vertically. Once we've done that, checked their units, and if they're not consistent, go ahead and convert them to something that is consistent. Maybe I had 60 minutes instead, or 30 minutes. I'll turn that into half an hour. We're going to express each ratio as a simplified fraction. And if the simplified fractions are the same, it's a true proportion. If not, they're not. The proportion is false. So that's method one. Method two says, again, check to make sure that the units are consistent, either vertically or horizontally. And then we're going to use cross multiplication. Cross multiplication between the two ratios. And we'll see examples of both of these methods in a moment. If the products are the same, then the proportion is true. If the products are different, the proportion is false. So method one says, let's simplify those. I happen to notice that 39 and 65 are both divisible by 13. That's not the easiest thing to notice. But if I do notice it, I can say, great, let's divide top and bottom by 13, and I get 3/5 on the left. On the right, I have 24/40. What goes into both of those? Well, 4 does. Maybe I could take out more, but let's start by taking out a 4. I get 6/10. So those are not the same, but we're not done. 6/10 I can divide by 2 and 2. What that means is I could have divided by 8 originally, 4 times 2. But this way it works too. 3/5. Now it's the same. Okay, so that's method one. Method two says just cross multiply. I'll rewrite this down here. 39 over 65 equals 24 over 40. Cross multiply. I have 65 times 24. And 65 times 24 is 130 times 12 is 1560. 1560. And then 39 times 40, well, that's 1 less than, or 40 less than 40 times 40, so also 1560. The two products are the same, so the ratios are the same. This is a true proportion. And I forgot to mention the very first thing. The first thing to notice is that there are no units, so it's trivially consistent. When we do have units, we have to check those absolute first thing. Take a look at page 38. 38, we have ounces per serving. Those are consistent horizontally. We've got ounces and ounces, servings and servings, so that's good. Step one, we're done. We've got method 1 and method 2. So method 1 says let's simplify these. Method 2 says let's cross multiply these. In both cases, they should either both be the same or both be different. Go ahead and figure out which one. As always, feel free to pause and do it now or save it for later. And then number 3, same thing. We're looking at the ratio. Are these ratios the same? In other words, is it a true proportion? Okay, page 39. Sometimes we want to find an unknown. So if we know that the relationship between quantities is proportional, we can use proportions to find the unknown quantity or the missing quantity. So n over 4 equals 25 over 20. We've kind of done this one already. We can either simplify down and say 25 divided by 20 is 5 over 4. And hey, look, n over 4 is 5 over 4, n must be 5. Or we can cross multiply. We can say 4 times 25 is 100. And n times 20 equals 20n. 100 equals 20n. So 1n, I just divide both sides by 20 and I get n equals 5. Notice that I flipped my sides. I didn't say 5 equals n. Technically, I could do it either way, but I generally have my variable first, even though the equality means that it could be either way. Okay, so both cases we found n must be 5. Number 2, we're looking at the length given the width, and we want to keep it the same as some other photograph. Make sure that you match up widths together and match up lengths together. Check those units, make sure that they're the same, and then you can figure out that length. One last check that I like to do is I always make sure that if, for example, the length is bigger here, then the length had better be bigger in that other photograph as well. If it's not, we probably got things switched a little bit. Okay, and let's, we've got one more page, I think, or more parts of this page, sorry. We have an hour to type 4 pages. We want to complete 27 pages. To do this, it's not going to be a whole number, so you're going to either need to use decimals, use fractions, use mixed numbers, or you could convert everything to minutes. Either way. Number 4, we've got 2 inches representing 17 miles. If it's 20 inches, how many miles apart are the 2 cities? So we've got a couple ways to do that. Again, whether you use the cross multiplication method, the simplification method. In this case, actually, the simplification method doesn't quite work, right? Because we have 20 inches, but I don't know how many miles apart they are. And 2 over 17 is already simplified. So this is a case where I would use the cross multiplication. 2 over 17, make sure I get my units in there. 2 inches over 17 miles equals 20 inches over X miles, or M or D, whatever we want to use, and go from there.